There are few places on Earth that look more final than Antarctica. From a distance, it appears complete in its silence. A continent of white, sealed under wind, locked beneath a brightness so immense that it can feel almost unreal. The ice seems less like weather and more like a verdict. It stretches across mountains, pours over valleys, fills old basins, and smooths the land into a pale, remote vastness that gives almost nothing away. If you were seeing it for the first time, with no map and no history, you might think this was how it had always been: cold, empty, permanent, a place outside the normal story of the world. But Antarctica is not outside the story at all. It is one of the deepest chapters in it. And before we settle into that chapter tonight, take a moment to subscribe if you enjoy these quiet journeys into the past. If you're listening from somewhere warm, or somewhere rainy, or in the middle of a very ordinary night, I'd love to know where you are in the world and what time it is there right now. That small thought always feels fitting with a story like this, because Antarctica has a strange way of making every other place feel close and every other hour feel temporary. When most people picture Antarctica, they picture the surface, the endless ice, the jagged blue walls of glaciers, the snowfields that seem to go on forever. Perhaps a few penguins near the coast, dark against the whiteness. Perhaps a research station lifted slightly above the ground on metal supports, as if even human buildings understand that they are only guests there. That image is not wrong. Antarctica is the coldest continent on Earth. It holds the largest single mass of ice on the planet. In places, that ice is so thick that it rises not in meters, but in kilometers. It covers almost everything the eye would normally use to read a landscape. Soil disappears, rivers vanish, old shorelines are buried, valleys are hidden. What remains visible is the lid, not the world beneath it. That is part of what makes the continent so powerful to the imagination. Ice simplifies. It smooths detail away. It removes the usual clues. On another continent, the land explains itself piece by piece. You can follow a road through hills, stand on bare rock, walk beside a river, notice layers in a cliff face, or see trees mark the edge of old water. In Antarctica, all of that is muted or erased from sight. The ice turns geography into silence. It becomes difficult to tell what lies below, and that difficulty has shaped the way people think about the continent. They do not think of it as a place with a hidden past. They think of it as a place with no past at all. And yet the truth is almost the opposite. Beneath Antarctica's ice lies a buried landscape, not a metaphorical one, not an imagined one, a real one. A landscape with mountain ranges, basins, river systems, canyons, ancient lake beds, and long-preserved sediments. In some regions, there are entire systems of valleys and subglacial waterways. In others, there are rock layers and fossil-bearing deposits that speak of forests, wetlands, warmer climates, and lives that unfolded there long before the modern ice sheets took control. Antarctica is not simply frozen. It is covering something. It is holding down a vast archive. To understand why that matters, it helps to begin not with the ancient past, but with the modern act of looking. Because for most of human history, Antarctica kept its secrets in a very straightforward way. It hid them under thickness. If a continent is buried beneath miles of ice, the ordinary tools of curiosity do not go very far. You cannot easily dig. You cannot move across the terrain the way you would elsewhere. You cannot stand at a ridge and understand the valley system below. Even landing is difficult. The cold interferes with equipment. Storms arrive with little kindness. Distance slows everything down. Antarctica is not merely remote in the sense of being far away. It resists examination. It makes knowledge costly. This resistance shaped the early age of Antarctic exploration. The first generations who moved toward the southern continent were dealing with coastlines, sea ice, survival, navigation, and endurance. They were encountering Antarctica as an immediate physical force, not as an ancient buried world. Their attention had to remain with what would keep them alive: wind direction, temperature, supplies, route choice, shelter. The surface demanded respect before deeper questions could even be asked. And for a long time, the surface seemed enough to define the place. Antarctica was the end of weather, the edge of habitability, the blank white margin at the bottom of the map. Only later did the buried questions begin to sharpen. One of the strangest things about scientific progress is that it often begins with a refusal to accept appearances. A landscape looks simple, so someone asks whether simplicity is only the view from above. A rock layer looks ordinary, so someone tests what is locked inside it. A continent looks dead, so someone starts measuring what lies underneath. In Antarctica, that shift mattered enormously. Instead of treating the ice as the continent itself, researchers began to treat it as a covering, a surface layer, a veil. That change in thinking opened the door to an entirely different Antarctica. Radar became one of the great instruments of this transformation. By sending signals through ice and reading what bounced back, scientists could begin to sketch what their eyes could never see directly. Hidden mountains appeared. Basins emerged. The underside of the ice sheet became legible in fragments, then in maps, then in broad models of the continent below. What had seemed smooth from above turned out to conceal a much rougher, older world. There were ridges as large as major mountain systems elsewhere on Earth. There were depressions deep enough to collect lakes under the ice. There were channels cut by ancient water, or later shaped by glacial movement. The white lid had covered a geography far more dramatic than the surface suggested. And radar was only one part of the story. Seismic work, gravimetric surveys, satellite observations, drilling programs, and ice core science all added different pieces to the puzzle. Ice cores, in particular, became famous because they did something almost magical. They turned ice into time. Layer by layer, trapped bubbles and chemical traces preserved records of ancient atmospheres, older climates, volcanic events, and shifts in planetary conditions. The ice was no longer just frozen water. It was memory in compressed form. Antarctica did not merely hide the past below. It carried parts of the past within itself. Still, the deepest fascination lay underneath. Because the moment you realize Antarctica is preserving records of older worlds, a more unsettling thought arrives right behind it. What kind of world had to exist there before all this ice took over? At first, the answer can feel difficult to accept. Antarctica is so bound to cold in the modern imagination that warmth there sounds like an error. Forests there sound impossible. Rivers there feel wrong. The mind resists them. We are used to thinking of continents as fixed in character. Deserts are desert-like. Tropics are tropical. Polar lands are eternally polar. But Earth does not honor those neat categories over deep time. Continents move. Oceans open and close. Currents shift. Atmospheres change. Temperatures rise and fall. Life expands, adapts, vanishes, and returns in altered forms. Antarctica, perhaps more than any other continent, teaches the cost of assuming that the present landscape explains the past. There was a time when Antarctica was not the isolated frozen fortress we know today. There were times when it was connected to other landmasses in a much larger southern world. There were times when its climate supported plants, when its soils formed under very different skies, when the edges of its land met waters that did not yet lock so completely into ice. Even without moving too far ahead in the story, the evidence already points toward a simple but profound truth. Modern Antarctica is not the original Antarctica. It is the final visible stage of a much longer transformation. You can feel the weight of that transformation in the very language scientists use when describing the continent beneath the ice. They speak of subglacial lakes, hidden ranges, buried topography, preserved sediments, ancient cratons, and concealed basins. These are not the words of a continent without history. They are the words of a continent with too much history to fit on its surface. Take the hidden lakes beneath the ice, for instance. Some of them have been sealed from the open air for astonishing lengths of time. They exist because the story below the ice is not static. Pressure, geothermal warmth, and the great weight of the ice sheet create conditions in which water can remain liquid even in a world dominated by freezing. Imagine that for a moment. Above, the coldest continent on Earth. Below, bodies of water held in darkness under immense pressure, isolated from ordinary weather, separated from the sky by thick ice. Even now, Antarctica contains layers of reality that do not match one another. Surface and depth belong to different moods of the same continent. Then there are the mountain ranges. Some rise high enough to influence the flow of the ice above them, even when they remain hidden from direct sight. Others form barriers and channels that shape where subglacial water moves and where sediments accumulate. Antarctica from above can seem smooth enough to erase geological drama. Antarctica below is full of it. There are places under the ice where the buried land is rugged, broken, elevated, or deeply cut. There are places where the continent preserves the memory of older tectonic events, older erosions, older landscapes inherited from worlds that vanished long before people ever imagined the South Pole. This is one reason Antarctica matters so much to the history of Earth. Not just because it is extreme, but because it is layered. It contains the surface world of modern polar conditions, the frozen record of more recent climatic history, and beneath that, the older ground of vanished environments. It is like reading a book in which the final chapter has frozen shut over everything that came before. And the deeper scientists looked, the stranger the place became. There are buried valleys that suggest ancient river systems. There are sedimentary basins that offer clues to long-lost ecosystems. There are fossils found in exposed Antarctic rocks near the margins of the continent that point unmistakably toward earlier worlds of plant life and animal life. Even where direct access is limited, the pattern keeps repeating. The ice is not covering emptiness, it is covering evidence. This evidence does not usually arrive all at once. It comes in fragments, a drill core here, a rock exposure there. A pollen grain, a leaf impression, a chemical signature, a geomorphic pattern revealed by remote sensing. Part of the quiet beauty of Earth science is that whole landscapes can be reconstructed from these modest clues. A single fossilized plant can imply climate conditions. A buried sediment layer can suggest standing water. A sequence of rock types can reveal environmental change over immense spans of time. Antarctica asks for that kind of patience. It rarely hands over its past in one dramatic gesture. It requires assembly, comparison, inference, humility. That humility is important because the buried world beneath Antarctica's ice is not one simple lost paradise waiting to be described in a single sentence. It is many worlds across many ages. The continent did not pass from green to white in one moment, and its history is not a clean before and after picture. It changed over tens of millions of years. Different regions changed differently. Some environments persisted while others vanished. Some records were preserved beautifully. Others were crushed, scraped, folded, or buried beyond easy reach. The lost world beneath the ice is real, but it is not simple. It is a layered memory of climates and ecosystems that rose and fell over immense stretches of time. And perhaps that complexity is part of what makes Antarctica so haunting. We live on a planet that is always changing, yet most human lives are too short to feel continental change as something real. We notice weather. We notice seasons. We notice bad winters, warm summers, storms, droughts, floods. But we do not naturally feel the pace at which a forest becomes a fossil bed, or a wetland becomes a buried sediment, or a continent drifts into a position where cold begins to gather year after year until ice takes command. Antarctica makes that invisible pace visible. It reminds us that permanence is often only a temporary appearance spread across a narrow slice of time. Imagine standing on the Antarctic plateau, where the wind can move fine snow like smoke across a surface already white beyond reason. There is no tree line to guide your eye, no exposed valley floor to suggest where water once moved, no ruined city, no carved stone, no obvious monument to the past. And yet beneath you may lie mountain roots older than the ice, sediment basins that once hosted life, hidden lakes in complete darkness, and rock records carrying traces of worlds warmer than our instincts would ever allow. It is hard to think of another place where appearance and reality are so completely divided. This is where the title of our journey begins to deepen. The lost world beneath Antarctica's ice is not lost because it vanished without trace. It is lost because the traces became unreachable, scattered, compressed, hidden under a continent-sized barrier that makes ordinary memory impossible. Human history prefers visible ruins. Antarctica offers almost none. Its history survives in ways that are less dramatic to the eye, but perhaps more profound. Encoded in fossils, carved into buried terrain, trapped in ice chemistry, sealed in sediments, and folded into the ancient architecture of the land itself. And there is something else here too, something that becomes clearer the longer one sits with the continent. Antarctica does not just hide the past, it changes our emotional scale for thinking about it. A buried road in an old city feels local. A lost harbor feels regional. A vanished forest beneath a modern field feels mournful, but familiar. Antarctica is different. Its buried past exists under such vastness that it becomes almost philosophical. The mind struggles to hold the proportion. This is not one hidden site. It is an entire continental memory under ice. A whole geography of forgotten conditions sealed away from ordinary touch. That is why the first real contradiction in Antarctica's story matters so much. The continent that looks most dead may be one of the richest surviving archives of ancient life and ancient climate on Earth. The landscape that seems to tell us the least may contain some of the deepest records of planetary change. The place that appears blank from above may be crowded below with the evidence of worlds that once breathed, grew, flowed, and changed. The more carefully you look, the less Antarctica resembles an ending. It begins instead to resemble a vault. Not a vault built by intention, but one formed by time, drift, temperature, burial, pressure, and unimaginable patience. Inside that vault are questions that stretch far beyond the continent itself. How warm was Antarctica at different stages of its past? What lived there and for how long? How did its ecosystems adapt to unusual patterns of light and darkness at southern latitudes? What happened as climate shifted and the ice advanced? Which records survive intact and which have been altered beyond recovery? And perhaps most importantly, What can this buried continent tell us about Earth's wider history of change? Those questions lead us away from the surface and toward the older Antarctica, the one our eyes can no longer see. Because once you accept that the ice is a lid, the natural urge is to ask what the continent looked like before the lid closed, what shape the land had, what colors it held, what moved through its forests, or along its riverbanks, or through the waters at its edge, whether it felt remote even then, or whether it belonged to a connected world that would now seem almost impossible. The white silence of Antarctica gives no easy answer. It only offers that immense stillness, as if the continent knows the size of what it is hiding. And under that silence, the older world waits. If you take the modern image of Antarctica and hold it in your mind for a moment, almost everything about the next part of this story will seem wrong. The coldest continent on Earth, the driest continent on Earth. A land of ice sheets, katabatic winds, fractured shelves, and horizons so pale they can erase the sense of distance itself. It does not feel like a place that could ever have been green. The very idea seems to push against instinct. We are used to imagining permanence in the broadest features of the world. Mountains may shift in shape. Forests may be cut down. Rivers may move. Coastlines may creep. But a continent at the bottom of the globe, wrapped in ice, feels as if it belongs permanently to cold. And yet the Earth has never been especially interested in preserving what feels intuitive to human beings. Over deep time, it rearranges the familiar. Warm places cool. Shallow seas vanish. Deserts bloom and then dry again. Forest belts migrate. Continents travel. The world we inherit is only one version among many. Antarctica, which now appears to stand outside the ordinary flow of life, is perhaps one of the clearest reminders that no landscape is born with its final identity already fixed. Long before Antarctica became the frozen citadel we know today, it belonged to a different Earth. Not a different Earth in the sense of fantasy, but in the sense that almost every large-scale condition we take for granted had another arrangement once. The continents were not where they are now. Ocean currents did not circulate in the same way. Carbon levels in the atmosphere were different. Temperatures were different. Ecosystems spread across routes that would later break apart. What is now the far south was once part of a much larger southern world, joined to other landmasses in the supercontinent known as Gondwana. To hear that name is already to begin leaving the modern map behind. Gondwana included lands that would, over immense spans of time, become South America, Africa, Antarctica, Australia, the Indian subcontinent, and other fragments of the southern hemisphere. Today, those places are separated by vast oceans and entirely different climates. But in the ancient past, they were connected. And that connection matters because it explains how Antarctica once participated in broader systems of climate, biology, and geology that now seem impossible from the perspective of its frozen isolation. When continents are connected, life moves differently. Plants spread across wider terrain. Animals follow corridors that later vanish. Rivers cross landscapes that are later torn apart by drifting plates. A forest growing in one region may have close ecological relatives thousands of miles away, because in the older geography, those miles did not yet exist in the same way. Antarctica was part of that older continuity. It was not merely a polar outpost. It was a living section of a greater world. This does not mean Antarctica was tropical in the simple postcard sense. Even in warmer eras, latitude still mattered, seasons still existed, and long cycles of light and darkness shaped life in ways that would have been unusual. But it does mean that the continent, or parts of it at different times, supported conditions far warmer and biologically richer than those of today. There were stretches of deep time when forests grew there. There were river systems. There were wetlands. There were soils forming under active ecological conditions. There were shorelines, floodplains, and living landscapes that cannot be reconciled with the modern Antarctic image unless one is willing to think on the scale of millions of years. That willingness is not always easy. Human memory is short, and our inner sense of history often struggles once the numbers become too large. 10 years feels real. 100 years can still feel textured. 1,000 years is already difficult to picture. But millions of years belong to a different mode of imagination. They demand not just patience, but surrender. You have to let go of the pace at which people normally think. Antarctica asks for that surrender from the very start. Its green past does not belong to the recent memory of the world. It belongs to geological time, which moves with such slowness that entire climates can ripen and die in what would seem, from the planet's perspective, like long breaths. How do we know this green Antarctica existed? Not because anyone saw it, of course, and not because the continent itself offers the kind of easy, broad visual evidence that a less buried landscape might. We know because the continent has left traces. Some are found in exposed rocks near the margins, where mountain building, erosion, or glacial action have revealed pieces of the older story. Others appear in sediments, fossil beds, pollen grains, preserved wood, leaf impressions, and chemical signatures that speak quietly but clearly of former climates. Antarctica's older life is not guessed at from nothing. It is inferred from evidence, assembled carefully, sometimes reluctantly, from records that survived immense pressure and time. Among the most evocative of these records are fossil plants. A fossil leaf may seem modest beside the grand scale of a continent, but it can carry extraordinary weight. The shape of the leaf, its structure, its veins, the kind of sediment surrounding it, the rock layer in which it is found, and the other fossils nearby can all help reconstruct an ancient environment. A single plant does not tell the whole story, but clusters of plant fossils, especially when matched with soils, wood, spores, and pollen, begin to describe a world. They tell us that Antarctica once supported vegetation not merely in isolated pockets, but across meaningful landscapes. The continent, or major parts of it during particular eras, once breathed in the quiet botanical way all green lands do. Petrified wood has been especially striking for many who study Antarctic history, because wood feels familiar in a way stone does not. You can look at fossilized trunks or fragments and immediately understand what they once were. They belong to trees. That simple recognition crosses immense stretches of time with unusual force. A buried trunk in Antarctic rock is not just a fossil. It is a contradiction made visible, a reminder that where ice now dominates, forests once stood. Those forests were not necessarily identical to any modern forest one could walk through today. Ancient ecosystems often combine features that now seem separated. Some had plant communities with no exact present-day equivalent. Others belong to climate systems unlike our own, shaped by atmospheric conditions, continental positions, and seasonal rhythms that no longer exist in the same form. Still, the broad truth remains clear. Antarctica was once green enough to sustain long-lived plant life, soils rich enough to support rooted landscapes, and climatic stability sufficient for ecological systems to develop and persist. That word, persist, matters. This was not a one-season accident, not a brief warming event in which a few hardy plants clung to a narrow coastal strip. The evidence points toward much more substantial biological histories than that. In different eras, Antarctica supported sustained environments capable of hosting layered ecosystems. Forests need more than a moment. Wetlands need repeated conditions. Rivers need hydrological continuity. Soils need time. Life, especially complex life organized across landscapes, requires duration. You can imagine, then, a very different Antarctic atmosphere from the one we know, not warm in the sense of tropical luxury, but green with mosses, ferns, seed plants, trees, damp ground in places, flowing water in others, perhaps long periods of summer light feeding steady growth. The strangeness of Antarctic seasons would still have mattered. At high southern latitudes, life would have adapted to unusual cycles of darkness and light. There may have been months when the sun stayed low but present, then long periods of dimness. Plants and animals living there would have adjusted to rhythms unlike those near the equator. That alone gives the ancient continent a peculiar beauty in the imagination. Not merely green, but green under an unfamiliar sky. This is one of the quiet wonders of prehistoric Earth. Its worlds were not just warmer or colder than ours. They were organized differently in ways that force us to widen our sense of what a living landscape can be. Antarctica's forests were not simply borrowed copies of temperate woodlands elsewhere. They belonged to a continent positioned in a strange latitude, connected to different neighbors, shaped by different atmospheric chemistry, and governed by a day-night cycle that modern listeners naturally associate with polar hardship. Yet life found form there. It spread, it rooted, it left traces enough for us to meet it again in stone. Pollen and spores add another layer to this meeting. These microscopic remnants can survive in sediments and provide intimate clues to vanished vegetation. They tell us not only that plants existed, but often what kinds of plant communities were present. Whole ancient environments can be sketched in part from these tiny, durable records. It is difficult not to admire the patience of such evidence. Giant ice sheets dominate the modern continent, yet some of the clearest messages from its greener ages arrive in particles so small they would vanish on a fingertip. Earth's oldest archives are not always dramatic. Often they whisper. There were also ancient soils, or what geologists call paleosols, formed under environmental conditions utterly unlike those of modern Antarctic ice cover. Soils are not passive dust. They are products of climate, biology, chemistry, and time. Their structure can reflect moisture patterns, plant activity, drainage, and weathering processes. A buried soil is a memory of a surface that once interacted actively with air, water, roots, and seasons. To find evidence of such surfaces in Antarctic history is to realize that the continent once functioned as a living land in ways the present surface no longer permits. The rivers matter too. Modern Antarctica contains meltwater features in some places and complex hidden water systems beneath the ice, but its surface is not the surface of a green fluvial continent. Ancient Antarctica was different. Sedimentary structures, geomorphic clues, and preserved deposits indicate that water once moved openly across parts of the land in river channels, across plains, through basins, and into larger hydrological systems. Rivers do more than carry water. They shape a continent. They cut valleys, sort sediments, nourish floodplains, support plants, and define habitats. To imagine rivers in Antarctica is to begin restoring movement to a landscape now dominated by frozen stillness. Where rivers flow, there are banks. Where there are banks, there are edges of ecological opportunity. Plants cluster differently there. Animals visit. Sediments accumulate. Floods leave records. Ancient Antarctica, in its greener chapters, would have been a world of such relationships. Not a silent white expanse, but a land of wet and dry zones, elevation differences, seasonal responses, and interacting forms of life. Even if its light was unusual, and its position near the southern reaches of the globe made it distinctive, it was still a functioning ecological world. There is something deeply moving in that thought. Beneath the continent now associated with absence lay long ages of presence. And perhaps that is why Antarctica's past feels so compelling even to people who do not usually think in geological time. The contrast is almost unbearable in its scale. A place now defined by cold once held forests. A place now described through emptiness once held layered living communities. A place now treated as remote from ordinary biological life once played host to it. The human mind responds strongly to reversal, and Antarctica offers one of the greatest reversals on Earth. But it is worth being careful here. The green Antarctica of the past was not the same in all periods. The continent's history spans vast stretches of time, and its conditions changed repeatedly. Some eras were warmer than others. Some ecosystems were more extensive than others. Some regions preserved evidence better than others. There is no single moment that explains everything. Instead, there is a long sequence of changing worlds, with Antarctica moving through different climatic phases as Earth itself transformed. During parts of the Paleozoic and Mesozoic eras, for example, the continent participated in environmental systems that allowed extensive vegetation and varied habitats. Different fossil assemblages reflect different times and different living communities. In some chapters there were swampy settings rich in plant matter. In others there were conifer-dominated forests. Later periods show additional complexity, including warm, high-latitude ecosystems that challenge easy assumptions about what polar regions must always have looked like. The buried Antarctic world is not one green picture. It is an album of green pictures, shifting across deep time. Some of the most famous plant groups associated with ancient Gondwanan worlds include glossopterids, seed ferns that spread widely across southern lands during parts of the Permian. Their fossils helped establish the reality that the southern continents had once been connected. This is one of those beautiful moments in science, where a plant becomes an argument. By finding similar fossil floras across now distant southern continents, researchers gained evidence that these lands were once part of a unified larger system. Antarctica's fossil plants were not just clues to local life. They were clues to planetary structure itself. This is another reason the continent matters so deeply. Antarctica does not simply preserve its own past. It preserves links between other lands. It remembers the age before oceans separated what now feels permanently apart. Through fossil similarity, rock correlation, and tectonic history, the continent becomes part of a wider narrative in which Earth's present map is revealed as temporary. The buried green world beneath Antarctic ice belongs to a time when the South had another shape, another continuity, another biological coherence. And because Antarctica later drifted into more isolated polar conditions, that older world was not merely transformed, it was sealed off. There is almost a tragic slowness in that sealing. No single curtain falls. Instead, the continent changes position. Climate systems evolve, atmospheric conditions fluctuate, ocean gateways open, and the ancient living surface gradually moves toward a new fate. The green world does not vanish overnight. It yields, it fragments, it cools. Forest by forest, basin by basin, age by age, Antarctica moves away from the environmental regime that once sustained lush life. The fact that this happens slowly makes it no less dramatic. In some ways, it makes it more so. A quick catastrophe shocks the mind. but a transformation unfolding across millions of years reaches deeper. It turns the entire continent into a lesson in patience and loss. Still, before the cold fully tightened its grip, there would have been long stretches when ancient Antarctica remained richly itself. Perhaps broad lowlands, where plants rooted in dark soil. Perhaps river corridors, lined with vegetation. Perhaps uplands, with different species adapted to elevation and seasonal stress. Perhaps coastal regions where marine and terrestrial systems met in productive exchange. Each piece of evidence recovered now is a surviving corner of that broader reality. The seasonality of light remains one of the most fascinating parts of the picture. Even in warmer ages, Antarctica's high latitude meant that life there had to contend with unusual annual rhythms. Imagine a forest that experiences extended summer daylight and then long winter dimness. Growth patterns in fossil wood, along with broader climate modeling and ecological inference, suggest that ancient plants adapted to these conditions in ways that reveal both resilience and strangeness. This was not simply a misplaced temperate forest. It was a southern forest, living on a continent whose relationship to the sun was already distinctive. That distinction likely shaped animals as well, though we will move more fully into them later. For now, it is enough to say that a green Antarctica was not merely an aesthetic reversal of the present. It was a functioning world whose organisms lived through patterns of light, temperature, and geography no modern Antarctic ecosystem remotely resembles. In that sense, the buried continent does not just contain history. It contains alternative versions of normal. It shows that life has repeatedly occupied modes the modern imagination would not invent on its own. There is also the question of warmth itself. What does it mean to say Antarctica was warm? It does not necessarily mean palm trees on every shore, or a tropical breeze where glaciers now break into the sea. Popular imagination often swings too sharply between extremes. The more careful truth is that Antarctica experienced periods warm enough to support vegetation, soils, open water systems, and robust ecosystems in regions where such things are impossible now. Some high-latitude climates in deep time were surprisingly mild, especially compared to modern polar expectations. Global greenhouse conditions, continental arrangements, and ocean circulation all helped produce worlds in which the polar extremes we know today had not yet fully developed. So when we say Antarctica was green, we are not using a poetic exaggeration. We are describing a continent whose buried evidence records real vegetated landscapes, real ecological structure, and real climatic conditions fundamentally different from those now reigning over the ice sheet. Green here means biologically active, rooted, watered, inhabited. It means the land once wore life on its surface, instead of hiding its memory beneath frozen mass. And what a strange surface that must have been. Not the hard, reflective whiteness of today, but textures of bark, leaf, mud, stone, water, mist, low-angle sunlight, seasonal decay, and regrowth. Sounds too, perhaps. Wind through branches instead of over open ice, insects in wetlands, water moving over sediment, the quiet cracking of wood in cold seasonal nights that were still nothing like modern Antarctic cold. The continent would already have had its remote vastness, but it would not yet have been silent in the same way. Silence is one of the strongest impressions Antarctica leaves now. Not absolute silence, of course. There is wind, ice fracture, distant bird life near some coasts, machinery at research stations, the groan of moving glaciers. But compared with a living continental surface, shaped by vegetation and abundant terrestrial ecosystems, the modern landscape feels muted. Ancient Antarctica, at least in its greener chapters, belonged to another acoustic world entirely. This can never be recovered directly, yet it lingers in the imagination once the evidence is accepted. The buried forests under the ice were not only visible places, they were inhabited places, places of movement, contact, seasonality, interruption, continuity, which is perhaps why their disappearance feels so powerful. Because the green Antarctica, reconstructed by science, is not simply a warmer map, it is a reminder that whole worlds can be covered without leaving ruins in the human sense. Forests do not need temples to matter. River systems do not need cities to become history. A continent can lose one identity entirely and still carry it, buried in stone and sediment. Antarctica's green ages are among the clearest examples of that truth. Nothing on the modern surface prepares you emotionally for what used to be there. The evidence must teach you slowly, layer by layer, until the frozen continent begins to look not blank, but overwritten. And once you begin seeing it that way, another question takes shape almost on its own. If Antarctica once held such landscapes, what kinds of creatures moved through them? What fed in their shadows, crossed their floodplains, nested at their edges, or adapted to their strange southern seasons? A forest implies more than trees. A river implies more than water. A living continent, however distant, tends to invite company. The green world beneath Antarctica's ice was never made of plants alone, and the next layer of its buried history belongs to the lives that once shared that land before the cold, slowly and patiently, began to close over everything. Once Antarctica becomes green in the mind, it refuses to stay empty. That is one of the quiet turning points in this story. In the beginning, the buried continent seems to be about land, climate, and the shock of discovering that ice is covering an older surface. Then, almost without warning, a more intimate question arrives. If there were forests there, who moved among them? If rivers crossed the land, what came to drink from them? If wetlands spread beneath ancient skies, what nested in the reeds? What hunted along the margins? What lived and died and left their traces behind before the ice ever formed? A continent covered in life is never made only of plants. Even a still landscape is filled with appetite, caution, growth, decay, breeding seasons, migrations, silences, alarms, and the constant exchange between one living thing and another. Ancient Antarctica was no exception. It was not simply a place where vegetation managed to survive in unlikely conditions. It was, at different times, a functioning world of creatures as well. That truth changes the emotional shape of the continent's past. A buried forest is one thing. A buried ecosystem is another. The first can feel like scenery. The second feels like a lost reality. It is also, in a strange way, easier to believe in ancient plant life than in ancient Antarctic animals. Fossil wood and leaf impressions sit comfortably inside the imagination once the climate explanation is accepted. But living creatures bring motion into the picture, and motion has a way of making prehistoric worlds feel real. A tree can belong to another age and still remain abstract. An animal crossing a muddy bank, pausing at the edge of water, lifting its head in long summer light, feels immediate. It breaks the spell of distance. The buried continent becomes inhabited. And yes, Antarctica was inhabited. Over the vast span of its history, the continent hosted different communities of life at different times. Some of these belong to older southern ecosystems linked across Gondwana. Some belong to later chapters when the world's climate remained warm enough for polar regions to support complex terrestrial life. The details shift from era to era, and the fossil record is never complete, but the broad pattern is beyond doubt. Antarctica was once part of living networks filled with animals, plants, insects, and marine creatures adapted to conditions that now seem almost impossible for that latitude. The idea of dinosaurs in Antarctica often surprises people most, perhaps because dinosaurs already occupy a borderland in the imagination between science and myth. To place them in Antarctica feels like layering one improbability on top of another. Yet dinosaur fossils have indeed been found there. Not in the deep central interior buried under the modern ice sheet, where direct access is almost impossible, but in exposed rock formations and regions where the continent's ancient story can still be read. These remains show that, during certain periods of the Mesozoic era, dinosaurs lived in Antarctica, just as they lived across many other parts of the world. This matters not because Antarctica was some special dinosaur kingdom apart from everything else, but because it was not a part. It participated in the great age of reptiles. It belonged to the same dynamic prehistoric Earth, in which large terrestrial animals ranged across connected continents, adapting to local conditions, while sharing broader evolutionary histories. The Antarctic chapter of that age is therefore not a novelty added to the margins. It is a reminder that the continent was once fully involved in the main flow of life on Earth. Still, its southern position gave that involvement a distinctive quality. Even in warmer ages, high latitudes meant unusual cycles of light and darkness. Dinosaurs living in Antarctic ecosystems would have experienced long summer days and prolonged winter dimness, though the exact severity varied depending on the era, the continent's position, and the climate conditions of the time. This is one of the most fascinating aspects of the buried Antarctic world. It was not simply warm enough for life, but organized around a pattern of seasonality unlike that of more equatorial regions. Creatures there had to live through extremes of daylight that feel inherently polar, even if the temperature regimes were far less hostile than those of the modern continent. What did that mean in practice? The answer is still pieced together through fossils, comparisons, and careful scientific imagination. Some animals may have migrated locally or regionally. Others may have endured the darker seasons through behavioral changes, altered feeding patterns, or biological rhythms suited to the environment. Plant growth cycles would have influenced food availability. Predators and herbivores alike would have been woven into a seasonal structure that made ancient Antarctica both fertile and unusual. It was not a simple paradise. It was a place requiring adaptation. Perhaps that is part of why it is so compelling. The animals of ancient Antarctica were not just familiar prehistoric forms, placed on an unfamiliar backdrop. They were participants in one of the strangest ecological experiments Earth ever sustained. Rich life at high southern latitudes, under skies that swung between abundance of light and scarcity of it. Some of the dinosaur remains found in Antarctica suggest herbivores and carnivores both had their place there. The fossil record is fragmentary, as polar fossil records often are, and every discovery tends to carry more weight because access is so limited. Yet even fragments can redraw a world. A bone, a tooth, part of a skeleton, a trace in rock, all of these help restore motion to a buried continent. Each find says, in its own quiet way, something once lived here long enough to leave a body behind. And bodies leave more than evidence of existence. They imply food webs. A herbivorous dinosaur implies plant life sufficient to sustain it. A predator implies prey. Nesting behavior implies seasonal stability. Growth patterns imply repeated years, not one lucky season. Once animals enter the Antarctic picture, the whole ecosystem deepens. Forests become habitat, rivers become corridors, floodplains become feeding grounds, wetlands become nurseries of insect life and breeding birds. The green continent below the ice stops looking like a broad botanical fact and begins to feel like a breathing world. Dinosaurs, though, were only part of the story. Antarctica's ancient life also included smaller creatures, earlier creatures, and marine life connected to surrounding seas. Insects likely moved through its vegetated environments, pollinating, feeding, decomposing, reproducing, living brief lives that nonetheless tied the whole ecological fabric together. Small vertebrates would have occupied niches between the larger dramatic animals that dominate public imagination. Birds or bird-like ancestors, depending on the era, had roles to play as well. The continent, like any real living place, would have been full of sizes and scales. That mixture matters because the popular mind tends to flatten prehistory into spectacle. It imagines giant animals first, and only later remembers that giant animals cannot exist without ordinary life around them. Ancient Antarctica would have had its less dramatic, but equally essential inhabitants: scavengers, burrowers, nest builders, water-edge feeders, small hunters, decomposers, and opportunists of all kinds. An ecosystem is not defined by its most famous creature. It is defined by relationships, and Antarctica had those too. Then there is the sea. No continent is fully understood without its margins, and Antarctica's coastal and marine environments once belonged to very different worlds than those of the present. In prehistoric and ancient warmer periods, the seas around Antarctica held life forms that made sense within those climates and geographies. Marine reptiles, fishes, invertebrates, and later birds and marine mammals in other time frames all contribute to the longer story of the southern continent. Water was never merely a border. It was part of the living system. Marine reptiles, in particular, help expand the buried Antarctic world beyond its land surface. During parts of the Mesozoic, oceans elsewhere on Earth were filled with large reptilian life adapted to marine existence, and evidence suggests that Antarctic regions were not excluded from such broader marine patterns. Coastal waters connected the continent to global biological circulation. Shorelines would have been transitional zones where terrestrial and marine worlds met, rich in nutrients, vulnerable to seasonal shifts, and alive with exchange. Imagine one of those ancient coasts for a moment. Not the severe ice front of today, where shelves crack into freezing ocean and seals rest on floating ice under a hard blue sky. Instead, imagine a shoreline shaped by sediment, vegetation inland, open water, not yet dominated by polar ice, a climate cool perhaps at times, but not lethal to complex biological richness. Birds or reptilian forms overhead, marine animals below, river water entering the sea through channels cut into a greener land. Whatever exact creatures filled a particular era, the larger truth remains the same. Antarctica's edge was once part of a vibrant interface between land and ocean. This matters especially because the fossil record of land life can be incomplete in places later scraped or buried by glacial activity. Marine sediments and coastal deposits sometimes preserve clues that help complete the wider ecological picture. They remind us that the lost world beneath Antarctica's ice was not a sealed garden in the interior alone. It included connections outward. It belonged to broader planetary systems of evolution and climate. Still, the land exerts the stronger emotional pull, perhaps because it is the land that now seems most impossible. To imagine animals walking across Antarctica is to feel the modern image of the continent give way more dramatically than when imagining marine life near it. The surface of today is so dominated by cold emptiness that even one prehistoric footprint would be enough to overturn instinct. And there were, in fact, ancient trackways and traces in the broader southern fossil world that help researchers think about movement, behavior, and environment in connected Gondwanan ecosystems. Direct Antarctic footprints are far rarer and harder to preserve or access than bones in exposed formations, but traces of movement elsewhere in related southern contexts support the larger reconstruction. Creatures did not merely exist there. They moved through real terrain shaped by seasons and necessity. Movement leads naturally to behavior, and behavior is where buried worlds become hardest to picture and most humanly interesting. Did Antarctic dinosaurs huddle through darker months? Did they migrate within local ranges following food and light? Did juveniles face harsher seasonal pressures than adults? Did some species breed during periods of prolonged sunlight when plant growth was strongest? Fossils cannot answer all of these questions directly, yet they invite them. And science, when careful, allows such questions to remain open while still using evidence to narrow possibilities. Bone structure, growth rings, sediment context, the anatomy of species found, and comparison with related animals elsewhere, all help scientists build models without pretending to know more than the record can support. This restraint matters. Antarctica is already mysterious enough without forcing certainty where evidence does not give it. The power of the buried continent lies partly in how much can be known, and partly in how much remains difficult to recover. It is one of those places where the boundary between reconstruction and humility must remain visible. We can say ancient ecosystems flourished there. We can say animals lived there, including dinosaurs. We can say forests and rivers supported complex webs of life. But the exact feel of a single Antarctic day in one prehistoric season must be imagined cautiously, guided by evidence rather than overtaken by fantasy. And yet careful imagination is still part of understanding. Picture, then, a floodplain in ancient Antarctica during a warmer chapter of its history. Not tropical, not lush in the overwhelming equatorial sense, but alive. Vegetation clustered thicker near water. Insects lift in brief clouds when the ground is disturbed. Small animals move first at the edges. A larger herbivore passes slowly, not because it knows anything of the future ice, but because this is simply its world. Soft ground, long light, a distant tree line, damp earth pressed by repeated feet. Somewhere beyond, a predator also belongs, neither strange nor legendary, simply fitted to a place that later ages would misread as eternally sterile. This kind of image matters because ancient ecosystems are easy to reduce to isolated fossils, but life is not lived as fossils. It is lived as presence, risk, hunger, mating, weather, and repeated days. The Antarctic fossil record is fragmentary, yes, but every fragment came from a living world once filled with ordinary biological routines. Creatures grew there, injured themselves there, fed their young there, searched for food there, and died there. The lost continent was not made of exceptional moments alone. It was made of lived time. That lived time included extinction as well. Over the deep history of Antarctica, different groups of life appeared, flourished, changed, and disappeared. Some extinctions were local. Some were global, tied to broader planetary crises that reached far beyond the southern continent. Antarctica did not exist outside those great biological turning points either. It participated in the same vast rhythms that shaped the rest of Earth: diversification, adaptation, collapse, replacement. The creatures of the buried continent were therefore not just inhabitants of a special place. They were citizens of Earth's larger changing history, subject to the same immense vulnerabilities. The end Cretaceous extinction, for example, which marks the fall of the non-avian dinosaurs, belongs to Antarctica's story, as well as to every other landmass that hosted them. Whatever form Antarctic ecosystems had taken by that time, they too would have been touched by the global disruptions unleashed by catastrophe. Darkness, climate disturbance, ecological breakdown, and cascading food web collapse would not have spared the far south. Antarctica's living communities have been buried by ice, yes, but they were also shaped earlier by the same planetary upheavals that reordered life everywhere. After the dinosaurs, of course, Earth did not become empty. Mammals diversified, birds continued, marine systems evolved, and Antarctica itself passed through later chapters in which life remained present under climates still far milder than today's. Fossils from post-dinosaur periods tell of forests and animal communities that existed in a world moving gradually, sometimes unevenly, toward colder conditions. The buried Antarctic story is not one long, uninterrupted dinosaur dream followed by instant ice. It contains many ages and many inhabitants. This longer view is important because it shows how ecosystems do not disappear all at once just because a continent is heading toward change. There are intermediate worlds, later forests, different animals, transitional climates. Antarctica carried life through multiple chapters before the full power of the ice sheets eventually transformed the continent beyond recognition. The buried animals of Antarctica therefore belong not to one lost world, but to a sequence of lost worlds layered across time. Perhaps that is why the continent feels so melancholy when imagined in this way. It lost not one identity, but many. There were ancient communities linked to Gondwana, later high-latitude ecosystems under warmer global climates, coastal webs of marine and terrestrial exchange, forested chapters with their own food chains. Each yielded, gradually or violently, to new conditions. Each left traces unevenly, and each is now flattened in the public imagination under the single word Antarctica, as if the modern ice were the whole truth of the continent rather than only its most recent mask. Bones help resist that flattening. A fossilized bone is a stubborn thing. It insists on a body, and a body insists on a world. You cannot have one without the other. This is why every Antarctic fossil discovery matters beyond its immediate classification. It does not simply add a name to a list of species. It reopens the continent. It tells us again that the land beneath the ice was once traversed, inhabited, contested, and alive. Even fragmentary finds carry that force. A jaw fragment, vertebra, tooth, limb bone, or marine fossil can redraw entire emotional maps. The same is true of nests, eggs, trackways, and other behavior-linked evidence, wherever such clues can be found in polar or connected southern records. Behavior is often harder to fossilize than anatomy, but when even indirect hints of it survive, they bring ancient Antarctica closer still. Reproduction happened there. Feeding happened there. Perhaps territoriality, migration, parental care, and seasonal congregation happened there too. The continent now associated with stillness once held repeated cycles of birth and movement. One cannot help wondering what the skies above ancient Antarctica looked like during those chapters. During long summers, light may have stretched across the horizon for extended hours, bathing forests and wetlands in a brightness more sustained than lower latitudes knew. During darker times, the atmosphere would have changed in mood entirely. How did animals respond to that? Did some time their breeding to the great light? Did plant cycles surge and then slow in marked pulses? Did young animals face a narrow window of abundance before leaner seasons closed in? These are not idle poetic questions. They are ecological ones, and high-latitude life always raises them. The Antarctic story encourages such attention because it is so unlike the easier prehistoric scenes repeated endlessly elsewhere. Deserts with dinosaurs are easy to picture. Tropical swamps with giant reptiles feel almost expected, but a fertile southern continent near the pole, alive under odd light cycles, demands more careful thought. Its strangeness is grounded, not theatrical. It is the strangeness of real life, adapting to real conditions that happen to defy modern expectation. There is another dimension, too, one quieter than bones or predators or giant herbivores, the world of decomposition. Ancient Antarctica, like every living continent, depended on death as much as life. Fallen plant matter would have broken down in wetlands and soils. Scavengers would have fed where they could. Insects and microorganisms would have participated in decay, returning nutrients to the system. Sediments would have buried some remains and erased others. Floods may have carried carcasses into channels. Lakes or oxbows may have trapped organic matter. Swamps may have accumulated dense layers of plant debris. Much later, pressure and time would transform some of these materials into the records scientists now read. The buried Antarctic world was preserved partly because ordinary ecological endings kept happening there. That can sound grim, but in truth, it is simply another sign of completeness. A partial ecosystem can look decorative. A complete one includes growth and death alike. Antarctica's past was complete in that sense. It held cycles. It was not a fragile exception. It was a true continental world, though one that would eventually be overtaken by changes too large for any local ecosystem to resist. And those changes were already waiting in the larger machinery of the planet. Continents drift even while creatures live their lives unaware. Ocean pathways open without warning to the forests inland. Atmospheric chemistry shifts over spans too large for any species to comprehend. Cooling begins not as an event but as a trend, then as a series of thresholds, then as a regime. The animals of ancient Antarctica did not know they were living in worlds that would one day be entombed. They simply belonged to their present, as all living things do. That is part of what makes the continent's buried ecosystems feel so poignant. Their inhabitants were not living in a prologue. They were living in a home. Yet from our viewpoint, those homes now seem suspended just before disappearance. This is where the story begins to tilt. Until now, Antarctica's past has been a revelation of unexpected life. Forests, rivers, dinosaurs, marine systems, seasonal abundance. The buried continent feels almost like a recovery, a gift returned to the imagination. But once creatures are restored to the land, another question becomes unavoidable. What happened to them? Not in the immediate sense of one extinction boundary or another, but in the larger sense. How did a world with food webs, coasts, inland habitats, and repeated living cycles become a world of ice thick enough to bury whole mountain ranges? The answer lies beyond any single species. It lies in drifting continents, changing ocean circulation, falling temperatures, and the patient advance of glaciation. The animals of the buried Antarctic world were not defeated by one enemy. They were overtaken by a slow planetary rearrangement. And the next step in this story is to watch that rearrangement begin, as a living continent moves, almost imperceptibly at first, toward the long white silence that would close over nearly everything it had been. The disappearance of Antarctica's older worlds did not arrive like a door slamming shut. There was no single morning when forests woke to find themselves under miles of ice. No one season in which rivers stopped, animals vanished, and the continent became what it is now. The burial of Antarctica was slower, deeper, and more patient than that. It was the kind of transformation only a planet can produce, because it required forces too large for any landscape to resist and too gradual for any living creature to fully perceive. Continents had to move. Oceans had to change their paths. Air had to cool in new ways. Thresholds had to be crossed one by one until the old world of soil, water, forest, and open ground gave way to something harder, whiter, and increasingly permanent. This matters because it changes the emotional tone of what happened there. A sudden catastrophe is easy to picture. Fire, impact, collapse, immediate ruin. But Antarctica's burial belongs mostly to another category of loss. It was not merely destroyed, it was replaced. Buried under a new climatic order so powerful and so long-lasting that it remade the continent's identity. The ancient living surface did not disappear because it was weak. It disappeared because the Earth itself rearranged the terms of survival. To understand how that happened, it helps to think first about the continent not as an isolated frozen mass, but as part of a slow planetary machine. Modern maps make continents feel stable because human lives are too short to notice their movement. Even 1,000 years reveals nothing obvious to the eye. But over millions of years, continents drift. They tear apart from larger assemblies, rotate, migrate, collide, and open oceans between one another. Antarctica's story is inseparable from that drift. When Antarctica was part of Gondwana, it belonged to a connected southern system. Land links meant ecological exchange, geological continuity, and different arrangements of ocean and atmosphere. But Gondwana did not last forever. Over long spans of time, it fractured. The lands that now seem naturally separate, South America, Africa, Antarctica, Australia, India, began to move away from one another. This was not a dramatic break visible in a single lifetime. It was a deep tectonic separation unfolding across ages, reshaping coastlines and eventually reorganizing the way water circulated around the globe. That reorganization would become one of the most important turning points in Antarctica's fate. Land and sea do not simply occupy different places on a map. Together, they control the movement of heat. Ocean currents transport warmth and cold, linking distant regions in ways that are almost invisible unless they change. A continent that sits connected to others can receive climatic influences very different from those acting on an isolated one surrounded by open water. For much of its earlier history, Antarctica's position and connections helped sustain conditions compatible with forests, wetlands, river systems, and rich ecosystems. But, as the southern continents pulled apart, something far more consequential than coastline aesthetics began to happen. Open pathways formed around Antarctica. Water could move differently. Isolation increased. Isolation, in Antarctica's case, meant cooling. One of the great forces in this transformation was the development of the circumpolar system, the broad pattern of ocean circulation that, once fully established, helped wrap Antarctica in cold water and cut it off from warmer currents. The most famous component of this in the modern world is the Antarctic Circumpolar Current, a vast flow moving around the continent. It is not the only reason Antarctica froze, but it is one of the most important pieces of the story because it changed the continent's relationship with the rest of the planet. Instead of receiving as much moderating warmth from connected ocean systems, Antarctica became increasingly enclosed within its own ring of cold circulation. That sounds almost abstract at first, but its consequences were enormous. Warmth that might once have reached Antarctic margins more easily was reduced. seasonal snow and ice could persist more effectively. Cooling became easier to maintain, and once ice begins to grow under the right conditions, it alters the landscape and climate further. Light is reflected. Elevation increases as ice builds. Weather patterns respond. The system begins to reinforce itself. Antarctica did not freeze simply because it drifted south and happened to become cold. It froze because drifting, isolation, atmospheric changes, and ocean circulation gradually worked together to create a new stable regime, one favoring ice. Atmospheric change mattered too. The Earth's climate history is shaped by greenhouse gases, volcanic activity, chemical cycles in oceans and rocks, the burial and release of carbon, and countless linked processes across deep time. Antarctica's burial cannot be explained by geography alone. The global climate had to cool enough, repeatedly enough, and durably enough to support the expansion of long-term glaciation. This was not just a local southern event. It was part of a broader planetary shift from warmer greenhouse worlds toward colder icehouse conditions. Still, the continent's geography made it especially vulnerable once those larger cooling trends intensified. Imagine an older Antarctica entering a cooler age in stages. At first, perhaps, seasonal snow lingers longer in uplands. Small glaciers begin forming in mountain regions that once saw only transient ice. River regimes alter. Vegetation zones contract or shift. Some lowlands remain habitable for a long time. Coastal belts may still support life familiar to warmer high-latitude systems. But the change has begun. The continent's living skin is no longer secure. In a world moving gradually toward cooler conditions, altitude becomes an early ally of ice. Mountain ranges catch snow, valleys preserve it. Glaciers begin as local accumulations, then grow, merge, and start to move. Ice is patient, but it is not passive. Given enough mass and slope, it flows. It pushes, scrapes, deepens, fills, reshapes. It can carve rock, capture sediment, dam water, and redirect the fate of landscapes below. Antarctica's mountain systems, many of them now hidden, likely played critical roles in how glaciation first organized itself and later expanded. This is one of the strangest parts of the continent's story. The land, buried under the ice, helped guide the ice that buried it. Ancient valleys became routes for ice flow. Basins became places of accumulation. High ridges influenced movement, pressure, and distribution. As glaciers spread and thickened, they did not descend upon a blank plain. They encountered an inherited world of rough topography, older drainage systems, buried structural highs, and sediment-filled depressions. The green world beneath Antarctica's ice did not vanish into featureless white. It was overtaken according to the shape of the land that had formed long before the full glaciation arrived. In some places, that likely meant destruction. A glacier moving across a surface with force can erode soils, grind rock, strip vegetation, and obliterate delicate evidence. In others, burial may have been more preserving than violent. Sediments could be sealed. Organic traces could be trapped in protected settings. Ancient landscapes could be capped rather than completely erased. This is one of the great paradoxes of Antarctica. Ice is both destroyer and guardian. It scrapes and shelters at the same time. The advance of glaciation would have transformed every major component of the old ecosystems. Rivers that once flowed openly would have been diverted, frozen, compressed beneath growing ice, or erased from the surface while leaving geomorphic memory below. Wetlands would have vanished as their hydrological balance changed. Forests would have retreated, fragmented, died, and eventually disappeared from the continent as climatic thresholds were crossed. Species adapted to older regimes would have moved, declined, or gone extinct locally. Every layer of the living world was tied to climate, and climate was shifting beyond their limits. Yet it is important not to picture this as one clean march of ice from coast to center or center to coast. Earth systems rarely behave so simply over millions of years. Glaciation likely advanced unevenly, with pulses, retreats, renewed expansions, and regional differences shaped by topography, precipitation, temperature, and the changing geometry of the continent. Some areas may have held on to milder conditions longer. Some ecosystems may have survived in refuges for extended periods. Others may have been overwhelmed earlier. Antarctica's transition from living continent to ice-dominated continent was a process, not a scene. That process is one reason the buried world feels layered rather than singular. Different parts of the continent would have entered the age of ice under different circumstances. Some forests may have vanished long before others. Some basins may have preserved ancient sediments under protective burial, while nearby uplands were scoured raw. Some coastlines may have shifted with sea level and changing ice margins again and again before the full modern system established itself. Antarctica was not simply frozen, it was progressively reorganized. There is something almost architectural about that reorganization. Picture old valleys becoming hidden corridors beneath future ice streams. Picture mountain flanks catching more snow year after year, until isolated glaciers begin to connect. Picture sediment basins once fed by rivers becoming sealed beneath cold mass. Picture the land's former surface water system gradually losing the right to remain on the surface at all. The continent's hydrology changes from open and visible to buried and pressurized. Eventually, even where liquid water exists, it does so under the rule of ice, not under the sky. This is how subglacial worlds begin to make sense. Modern Antarctica contains lakes and water systems beneath the ice, not because the continent somehow escaped freezing below, but because pressure, geothermal heat, and the complex behavior of thick ice create conditions in which water can persist in hidden forms. These are not leftovers from the Green Age in any simple, direct sense. They are products of the ice-dominated world, but they also point back to the burial process itself. A continent that once had ordinary rivers and lakes now has hidden ones. Water did not leave the story. It changed roles. It moved underground, under pressure, into darkness. The growth of ice sheets marks the decisive stage of this transformation. A glacier can shape a landscape. An ice sheet can dominate a continent. Once Antarctica accumulated enough long-term ice to support large, stable ice sheet systems, the balance tilted hard against the older living surface. Ice sheets are heavy beyond easy comprehension. They depress the crust beneath them. They spread over enormous distances. They influence weather, sea level, albedo, ocean conditions, and erosion patterns. They turn local climate into continental climate. At that point, what had once been a changing landscape of forests, animals, rivers, and seasonal variety became increasingly unified under one ruling material. Ice is unusual in that way. It can function at once as weather, geology, and architecture. It falls from the atmosphere, flows like a slow mineral river, and builds structures vast enough to rival mountain systems in visual and physical presence. Once Antarctica entered its great age of ice, the old land did not merely become colder, it became subordinate. That subordination can sound total, but again, the truth is subtler. Even under ice, the older world continued to matter. It shaped the flow of glaciers. It influenced where erosion was strong and where sediments accumulated. It determined which ancient valleys became hidden troughs and which mountains resisted complete burial. The green Antarctica of the past was not annihilated into nothingness. It was incorporated into the mechanics of its own concealment. Some of the most haunting evidence of this comes from buried landscapes that remain recognizable beneath the modern ice. Radar and other remote sensing techniques reveal ancient river valleys, mountain ranges, and topographic forms that belong to the pre-ice world or were inherited from early stages of glaciation. These features are astonishing not because they are spectacular in themselves, though many are, but because they survive at all. They tell us that Antarctica's past was sealed, not simply ground away. The lid grew thick enough in places to preserve the shape of older land. Think of the emotional difference between erasure and burial. Erasure leaves absence. Burial leaves presence hidden from view. Antarctica contains much more burial than people often imagine. This is especially true in sedimentary basins and protected regions where ancient materials could be sealed beneath advancing ice and later remain inaccessible but intact enough to retain records of climate, vegetation, or environmental change. The continent's older histories are therefore not just remembered in exposed rocks at its edges. They are, in some cases, physically trapped under the ice itself, waiting behind a barrier so immense that retrieval becomes one of the great technical challenges in Earth science. There is also the matter of time once the ice had taken hold. The continent did not instantly become the exact Antarctica of today. Ice ages fluctuated. Ice sheets expanded and contracted in response to broader climatic cycles. Some areas may have seen dynamic edges, advances, retreats, re-advances, yet over long spans, the direction was clear. Antarctica was increasingly a frozen continent, and the older worlds below were increasingly inaccessible. Every expansion of ice deepened the separation between surface appearance and buried truth. One can imagine the last forests of Antarctica, though they would have belonged to very ancient chapters long before modern humans existed. They did not know they were last. Of course, trees never do. They simply respond to conditions until response is no longer enough. Temperatures shift, growing seasons shorten or alter, water regimes change, frost patterns intensify, reproduction falters. Competitive balances shift. A forest does not need a dramatic ending to end. It can thin, fragment, fail to renew itself, and pass into absence so gradually that only the fossil record later realizes what has happened. The same is true of river systems. A river can be lost by drying, diversion, burial, freezing, or glacial overrun. Its channel may remain as a form below later deposits or beneath ice. Sediments once laid down in moving water may survive long after the water itself has ceased to flow in the open. Antarctica likely contains many such memories. Hydrological histories preserved without living rivers, still visible at the surface. That is one of the continent's most powerful lessons. Landscapes do not forget, even when they can no longer show their faces. As the ice thickened, it must also have altered the very relationship between the land and the sky. A living continental surface exchanges heat, moisture, gases, and energy with the atmosphere through soils, vegetation, water bodies, and seasonal change. Ice sheets simplify that exchange in some ways and amplify it in others. They reflect sunlight, shape wind patterns, and suppress much of the local ecological texture that once helped define climate near the ground. The atmosphere above glaciated Antarctica increasingly belonged to a different continent than the one below. Surface and buried land diverged not only physically, but climatically. This divergence created the Antarctica people would one day encounter the bright, hostile, silence-dominated world that gives almost no sign of the lives and landscapes beneath it. By the time humans entered the story and began imagining the far south, the old living continent had already been hidden for immense spans of time. Exploration, therefore, began with misreading, almost inevitably. People met the ice first and assumed the ice explained everything. Only much later did science begin to peel back that assumption. Yet even now, the burial is not complete in the philosophical sense, because the old world keeps pressing upward through evidence. Exposed fossil forests near mountain regions, plant remains in Antarctic rocks, ancient sediments offshore and at continental margins, subglacial topography revealed by remote sensing, hidden lakes and valleys indicating a land not born white but made white. The continent's history pushes against its own concealment. That tension is what gives Antarctica its special power in the story of Earth. Many landscapes preserve ancient climates, many regions carry fossil memories, but Antarctica preserves them under dramatic contradiction. Its surface tells one story, while its buried geology tells another. The white stillness above says frozen finality. The hidden land below says change, warmth, rivers, life, and long transformation. To study Antarctica is therefore to learn how misleading the visible present can be when stretched over geological time. There is also a quiet warning in it. If an entire continent can shift from forested ecosystems to an ice-dominated vault, then Earth's surface identities are far less permanent than they feel. Antarctica is not only a memory of deep time, it is evidence that climate systems, once reorganized sufficiently, can completely rewrite the face of a land. That rewriting took millions of years in this case, and it belongs to conditions beyond any simple modern comparison. But the principle remains humbling. Continents do not stay what they seem. And still, for all the power of the ice, something remarkable happened. The burial that might have erased everything instead created one of the greatest archives on Earth. Because once enough of the continent lay sealed beneath stable ice, ancient surfaces, sediments, chemical records, and topographic forms could persist in ways they might not have in a more open, actively weathered environment. Some records were certainly destroyed. Some chapters are gone forever. But others were protected by the very system that hid them. Antarctica's cold tyranny became, over time, a preservative force. The lid that separated the old world from sight also shielded parts of it from later disturbance. This is the paradox at the heart of the continent's buried history. Ice ended the living world we have been imagining. It pushed forests out, reworked rivers, covered basins, and turned open land into a polar stronghold. Yet in doing so, it also stored clues to what it had replaced. It locked atmospheric history into ice cores. It protected buried forms of the land. It sealed ancient sedimentary records. It made access harder than almost anywhere else on Earth, but it also prevented easy loss. So, Antarctica's burial was never just an ending. It was a conversion. A living continent became a frozen archive. A world of open ecological relationships became a world of hidden records. Trees turned to fossils, rivers to buried valleys, climatic warmth to chemical traces, exposed landscapes to subglacial maps. The old world did not survive in the form it once knew, but neither did it vanish without witness. The witness is everywhere beneath the ice if one learns how to read it. And that is where the story turns again. Because once you understand how a living world was buried, the next question becomes impossible to avoid. What, exactly, is still down there? Not in the imaginative sense now, but in the practical one. Which mountain ranges remain hidden but intact beneath the ice? Which valleys preserve ancient drainage patterns? Which sediments still hold evidence of vanished climates, forests, or ecosystems? Which subglacial lakes and buried basins may be protecting records older and stranger than we yet fully understand? Antarctica's deep burial did not close the investigation. It created it. The white surface above may look like a finished sentence, but under that sentence, the continent is still full of unread lines. Once you understand that Antarctica was not born as a continent of endless white, the modern surface begins to feel less like a landscape and more like a cover. Not an empty cover, not a false one, but a cover all the same. Something real lies beneath it, something vast, layered, and in many places still untouched by ordinary access. This is where the story becomes especially powerful, because it moves from reconstruction into pursuit. We are no longer speaking only about worlds that existed and vanished. We are speaking about worlds that, in important ways, are still there. Not alive in the old sense, of course. The forests do not stand waiting in darkness. Dinosaurs do not move beneath the ice. Rivers do not run openly under Antarctic sky. But the forms of the older continent and the records of what it once was remain hidden under that enormous frozen weight. Mountain ranges still shape the underside of the ice sheet. Valleys still guide the flow of ice and subglacial water. Sediments still sit in buried basins. Ancient chemical and climatic evidence remains locked in places so inaccessible that even reaching them can become a scientific achievement in its own right. That is what gives Antarctica such a strange place in the history of knowledge. On many continents, the past is difficult to interpret because it has been exposed for too long, weathered, built over, eroded, altered by vegetation, rivers, cities, and ordinary time. Antarctica presents the opposite problem. Too much is preserved behind too much barrier. The challenge is not that the evidence is gone, but that it is sealed. This sealing has forced scientists to become unusually inventive. If the land cannot be walked easily, it must be sensed indirectly. If the ancient surface cannot be observed with the eye, it must be modeled from signals, reflections, and buried patterns. If the sediments cannot be broadly excavated, narrow windows must be created into them through drilling and carefully chosen sites. Antarctica asks science to work like listening through walls. And over time, the walls have become less silent. One of the most extraordinary tools in this effort has been radar sounding. By sending radio waves through the ice and measuring what returns, researchers can map the bedrock surface below and reveal the shape of the buried continent. What this has shown is astonishing. Beneath the broad visual simplicity of Antarctica lies a hidden geography of mountains, canyons, basins, ridges, and troughs. Some of these landforms are so large that if they were exposed, they would be recognized immediately as defining features of a major continent. Yet, because they are buried, they exist in the public imagination only faintly, if at all. Consider the hidden mountain systems under the ice. Modern people tend to think of Antarctica either as a flat, frozen desert or as a place of coastal glaciers and dramatic ice cliffs. But large parts of the continent conceal far older and far rougher terrain. Some mountain ranges rise high enough beneath the ice to influence the flow above them in visible ways, even though the mountains themselves cannot be seen directly. The ice drapes over these hidden forms, accelerating in some places, bunching in others, changing shape according to the buried land below. In a sense, the continent still writes through its covering. There is something quietly moving about that. The hidden land has not ceased to matter simply because it has disappeared from view. It continues to guide the present, even while carrying the memory of a vastly different past. Then there are the valleys. Some of the buried valleys beneath Antarctica are ancient features inherited from landscapes older than the ice sheet itself. They may have been carved by rivers in warmer times, or modified across multiple phases of erosion and glaciation. Others were deepened or reshaped by ice, as the frozen age took over. Distinguishing one kind of history from another is part of the scientific challenge. Yet, whatever their precise sequence, these troughs and channels remind us that the continent below the ice is not shapeless. It is legible, if slowly, and often surprisingly intact. In some cases, buried valleys help reveal the logic of older drainage systems. A river that no longer exists may leave behind a topographic memory of its path. A basin that no longer collects open water may still preserve its structure under ice and sediment. This is one reason Antarctica matters so much in the study of ancient climate and landscape evolution. The continent contains not only isolated fossils and rock outcrops, but traces of whole systems that once organized water, life, weathering, and sediment transport across large distances. And beneath some of that ice, there is still water. Subglacial lakes have become one of the most fascinating features of modern Antarctic science, partly because they sound almost impossible when first described. A lake under a continental ice sheet, sealed from the open sky, hidden in darkness, and, in some cases, potentially isolated for immense periods of time. Yet these lakes are real. They exist because thick ice creates pressure, because geothermal heat rises from below, and because the interaction between temperature, pressure, and topography allows liquid water to persist in certain environments, even under extreme surface cold. The most famous example for many years has been Lake Vostok, buried beneath kilometers of ice in East Antarctica. Even the basic existence of such a lake challenges intuitive ideas about the continent. Antarctica is supposed to be frozen through and through, but it is not. The deeper reality is more complicated. The continent is layered, and some of its most intriguing modern features belong to this hidden layer, where pressure, isolation, and geological history meet. Lake Vostok is compelling for several reasons. First, it is vast. Second, it has potentially been isolated from direct atmospheric contact for an immense length of time. Third, anything preserved in or around such a lake's sediments, chemical signatures, microbial life, mineral interactions could tell us something about long-term isolation, extreme environments, and the hidden history of the continent. There has been understandable caution around accessing such environments, because drilling into them carries the risk of contamination. But even without reckless intrusion, their existence broadens the meaning of Antarctica. It is not just a frozen surface covering inert rock. It is an active hidden system. And Lake Vostok is only one of many subglacial lakes identified beneath Antarctica. Some are smaller. Some appear to fill and drain over time in complex ways. Some connect, directly or indirectly, to larger subglacial hydrological systems. Water moves under the ice more dynamically than many people imagine. It can lubricate flow, pool in basins, drain through channels, and interact with sediments in ways that affect both the stability of the ice sheet and the preservation of buried records. Antarctica's hidden world is therefore not just ancient in the passive sense. It is still physically active. This is an important point, because the buried continent is not a museum in the neat human sense. It is not arranged for viewing. It has not sat untouched by all processes. Ice moves. Water moves. Sediments shift. Pressure changes. Some records are preserved exquisitely, others are distorted or destroyed, and still others remain beyond enough access to classify with confidence. Antarctica is not a glass case. It is a dynamic archive, one in which preservation and disturbance coexist. Sediments are among the most valuable parts of that archive. Wherever sediments accumulate in relative protection beneath ice shelves, in offshore basins, in subglacial depressions, or in ancient depositional settings now buried, they can preserve chronological sequences of environmental change. A sediment core is, in a sense, a timeline made of matter. Grain size, mineral composition, organic traces, pollen, spores, isotopic chemistry, and other details can reveal whether a place was once marine, freshwater, forested, swampy, glaciated, or something transitional between these states. In Antarctica, such sediments are especially precious because they may record phases of the continent's past that are otherwise almost invisible from the modern surface. This is why drilling campaigns and core analysis play such an important role in Antarctic science. A narrow cylinder of sediment or ice can become a deep record of lost climate. Scientists read these materials layer by layer, much as one might read a very slow book whose language is chemical and structural rather than verbal. A coarse layer may suggest energetic deposition. Fine laminations may imply calmer water. Organic content may hint at biological productivity. Isotopic shifts may point to temperature changes or evolving ocean conditions. It is a patient form of reading, but Antarctica rewards patience more than almost any other place. Ice cores, though often associated more with climate than landscape, are another great source of hidden Antarctic history. They preserve ancient air in trapped bubbles. They record volcanic ash, dust transport, greenhouse gas concentrations, and temperature proxies extending far back in time. These records do not directly show a buried forest or an ancient animal, but they tell the atmospheric story surrounding the transformation of the continent and the planet. They reveal the rhythm of ice ages, greenhouse shifts, and climatic instability. In that sense, they are part of the same archive as the buried landforms and fossil-bearing rocks below. Antarctica does not preserve only what lay beneath the ice. It preserves something of the air above it, too. The combination is remarkable. A single continent stores topographic memory under the ice, atmospheric memory within the ice, and ecological memory in rocks and sediments at its margins and below its frozen covering. Few places on Earth hold such different categories of time in one body of land. Remote sensing from satellites has expanded this picture further. From orbit, Antarctica can be studied in ways earlier generations could hardly have imagined. Surface movement, subtle changes in elevation, gravitational anomalies, ice thickness, and buried structures all become more legible when observed from above with repeated precision. Satellites cannot magically reveal everything, but they make the ice less opaque in strategic ways. They allow patterns to emerge over enormous scales, and Antarctica demands that scale. It is too large, too cold, and too remote to rely on local observation alone. What these combined methods have revealed is a continent far more complex than the old image of blank whiteness. There are hidden canyons cut deep into the subglacial bed. There are deeply buried basins that may contain ancient sediments of exceptional importance. There are mountain blocks and structural provinces reflecting the continent's geological inheritance from older tectonic worlds. There are regions in East Antarctica thought to preserve especially ancient landscapes, perhaps some relatively little altered under long-term cold conditions once they were sealed. There are also areas in West Antarctica where the bed lies far below sea level, making the relation between ice, ocean, and buried land especially delicate and scientifically important. East and West Antarctica differ in ways that matter greatly to the story of what lies beneath the ice. East Antarctica contains the great old cratonic heart of the continent in many regions, geologically ancient and in some places thickly armored by long-term ice. West Antarctica, by contrast, includes more complex tectonic histories, lower bed elevations in many places, and greater vulnerability to marine influences under current conditions. This difference means that the hidden records are not distributed evenly. Antarctica is one continent, but it contains multiple geological personalities, each with its own form of concealment. The offshore record matters as well. Much of Antarctica's history, especially the story of how its climate and ice sheets evolved, is written not only under the present continental ice but in marine sediments around its edges. As glaciers advanced and retreated, as rivers changed, as erosion stripped material from the land, enormous quantities of sediment were carried into surrounding seas. There, layer upon layer, the continent deposited indirect testimony about itself. Scientists reading offshore cores can sometimes infer what was happening inland long before direct evidence is accessible under the ice. In that sense, the sea has become Antarctica's secondary memory. There is something almost elegant in that. When the continent could no longer show its face directly, it began writing letters outward in sediment. And still, much remains beyond reach. This is perhaps the most exciting and humbling aspect of Antarctica's hidden world. For all the advances in mapping, drilling, imaging, and analysis, vast regions remain known only in outline. We have shapes where once there was blankness but not full stories. We have clues where once there was ignorance but not complete reconstruction. Some buried basins may contain invaluable sedimentary archives that could transform understanding of polar climate evolution, ancient ecosystems, and continental history, yet they remain inaccessible under thick ice and extreme conditions. Some subglacial environments may host microbial life adapted to isolation and pressure, yet careful access is technically difficult and ethically delicate. Some landscapes have been mapped in broad form, but not sampled closely enough to tie them securely to specific ages or environments. This unfinished quality is part of Antarctica's pull. It is not merely a place where science has discovered surprising things. It is a place where the act of discovery is still underway, in a very literal sense. Take subglacial microbes, for example. The idea that microbial life might persist in isolated Antarctic environments beneath the ice has captured attention because it touches several deep questions at once. How resilient is life in extreme conditions? What chemical pathways sustain it when sunlight is absent? How long can ecological isolation last and still preserve biological activity? Such questions matter not only for Antarctic science, but for our broader understanding of life's adaptability on Earth, and perhaps beyond it. Yet again, Antarctica must be approached with restraint. To reach such environments is to risk altering them. Even knowledge here must move carefully. There are also buried sedimentary records that may contain pollen, spores, plant fragments, and geochemical indicators from warmer periods of Antarctic history. These are especially valuable because they can help pin down when parts of the continent supported vegetation, how climates shifted across transitions, and how quickly or slowly major changes unfolded. A single core, if taken from the right place, can narrow uncertainties that have remained open for decades. But the right place under Antarctic conditions is rarely easy to identify or reach. The continent's archive is rich, but it does not offer convenient shelves. All of this reinforces a central truth. Antarctica is not only the site of a buried world, it is a test of how we learn about buried worlds at all. Elsewhere, archaeologists may brush away soil from stone walls or uncover graves, roads, foundations, pottery, bone. Antarctica almost never offers such direct intimacy. Its secrets are mostly not human-made, and even the natural records are often sealed beneath ice too thick for ordinary excavation. The methods are larger, more technical, less romantic to the eye perhaps, yet no less profound. A reflected radar signal, a pressure reading, a trace gas, a microscopic grain of pollen, a sediment horizon detected kilometers below the surface. These are the tools by which a lost continent begins to speak. And speak it does. Every hidden range mapped under the ice says that the land endured. Every buried valley says that water once shaped this continent openly, or that glaciation later sculpted it in ways still readable now. Every subglacial lake says that Antarctica remains physically alive beneath its frozen face. Every sediment core says that the buried past is not fantasy, but evidence, waiting in layers. Every ice core says that the atmosphere itself once changed in rhythms large enough to create and sustain this frozen empire. The continent may appear silent, but in scientific terms, it is full of voices. Perhaps that is why Antarctica inspires such an unusual mix of awe and patience. It is not like a ruin you can walk through in an afternoon. It is not even like a fossil bed you can stand beside and see with your own eyes. It asks for trust in indirect knowing. It asks for comfort with partial revelation. It asks us to accept that the truest map of a place may be the one hidden under its surface and assembled only through years of careful work. There is also a philosophical dimension to what still lies beneath the ice. Hidden continents, buried valleys, isolated lakes, ancient air trapped in ice, sediments preserving vanished climates. These things alter the way we think about history itself. We often imagine history as a sequence of visible events, but Antarctica suggests another model. History can be sealed. It can survive without display. It can remain materially present for millions of years, while seeming absent to the living world. The lost world beneath Antarctica is therefore not simply an object of curiosity. It is a lesson in how much reality can exist beyond immediate sight. And that lesson extends beyond geology and paleoclimate. Because what still lies beneath Antarctica's ice does not matter only for understanding Antarctica. It matters for understanding Earth as a whole. The continent's hidden records can tell us how greenhouse worlds functioned, how polar regions responded to warming and cooling, how ice sheets grew, how sea level shifted, how ecosystems adapted at high latitudes, and how continental arrangements transformed climate itself. Antarctica is not just preserving local memory, it is preserving planetary memory. This is why every buried basin, every subglacial lake, every hidden mountain range carries meaning beyond its immediate scientific category. Each one is a fragment of Earth's larger autobiography, locked away under the least welcoming continent on the map. And the more this becomes clear, the more the final question deepens. If Antarctica is holding so much landscape, climate, atmosphere, ecosystems, transitions, thresholds, then perhaps the buried continent is not merely a strange chapter in Earth's past. Perhaps it is one of the greatest archives the planet has left, a place where entire worlds were not only lost, but stored. By the time a story reaches Antarctica, it often sounds like it has reached the end of the world. That is how the continent appears in the human imagination, a white margin, a final silence, a place where history gives way to weather and where life retreats to the edges. For much of modern culture, Antarctica has stood less as a chapter in Earth's story than as a blank page beneath it, a continent of ice, wind, distance, and almost unbearable stillness. A place so extreme that it seems to exist outside the ordinary movement of time. But by now, that illusion has changed. The ice has not erased Antarctica's history. It has hidden it. And because it has hidden it so completely, it has done something unexpected. It has turned the continent into one of the greatest sealed archives on Earth. That idea deserves a slow and careful ending, because it is the real answer to the title of this journey. The lost world beneath Antarctica's ice is not important because it hides one dramatic secret or one isolated prehistoric wonder. It matters because the continent preserves entire categories of Earth's memory in one place: landscapes buried beneath ice, fossils from vanished ecosystems, sediments recording long climate shifts, ice cores storing ancient atmospheres, hidden lakes and basins carrying the signature of deep isolation. Antarctica holds not just a lost world, but many lost worlds, stacked, sealed, and partially protected by the very conditions that made them so difficult to reach. In that sense, Antarctica is not merely a frozen continent. It is a memory vault. The phrase may sound poetic, but the science behind it is very literal. Archives preserve records. They protect traces from decay, even if access becomes difficult. That is exactly what Antarctica has done across vast stretches of time. The growth of the ice sheets transformed the continent into an environment hostile to easy life and easy exploration. But in doing so, it also preserved clues that, elsewhere, might have been weathered away, overrun, scattered, or lost in more accessible landscapes. The continent's cold silence became a kind of storage. This is where the Antarctic story stops being only regional and becomes planetary. If you recover a fossil forest from one buried layer of Antarctic history, you learn that the continent was once green. But if you place that forest into its broader climate context, then examine sediments offshore, compare atmospheric records in ice cores, map the ancient topography beneath the ice, and track the tectonic changes that isolated the continent, you begin to see something much larger. Antarctica is not only telling us what it used to be, it is telling us how Earth itself changes, how climates move between warm worlds and cold ones, how continents shift from connection to isolation, how ecosystems rise in conditions that later vanish, how apparent permanence is often only the latest arrangement. This is why the continent matters so deeply to anyone trying to understand Earth's true history. It preserves evidence of worlds that no human being ever saw, but which nevertheless shaped the planet we inherited. And there is something humbling in that phrase, true history. Human beings often use the word history to mean the part of the past we can remember through writing, ruins, kings, roads, borders, trade routes, wars, and recorded speech. That is understandable. It is the past we know how to narrate most easily. But the Earth's true history is much older, much stranger, and much less interested in us than our own stories are. It includes forests that grew and vanished before mammals ruled the land. It includes atmospheres richer or poorer in greenhouse gases than those under which human civilization emerged. It includes oceans opening where no ocean had been, continents separating where land once flowed across enormous distances, and climates changing so profoundly that a green world can be entombed beneath a frozen one. Antarctica preserves pieces of that deeper history with unusual clarity. Not complete clarity, of course. No natural archive is perfect. Some records are broken, compressed, reworked, or missing. Some landscapes beneath the ice remain mapped only in outline. Some sediments are still beyond reach. Some ecosystems can be reconstructed only through scattered clues. The archive is real, but it is incomplete, and that incompleteness matters. A sealed archive is not the same as an easy one. Antarctica still asks for patience, caution, and humility. It gives enough to transform understanding, but never so much that interpretation becomes effortless. Perhaps that is why it remains so compelling. It is not only a storehouse of answers, it is a storehouse of better questions. What did the earliest long-lasting ice on Antarctica really look like, and how unevenly did it spread? Which buried basins still hold plant records from the warm, high-latitude forests of the past? How did ancient organisms adapt to the long, strange light cycles of the southern continent? What histories remain in subglacial sediments no drill has yet touched? Which landscapes beneath East Antarctica have been preserved most faithfully beneath long, stable ice, and which have been altered beyond recognition? How many thresholds did the planet cross before the Antarctic cryosphere became strong enough to dominate the continent as it does today? These are not small questions. They are questions about Earth's operating system. That phrase may sound modern, but it captures something important. Antarctica does not just preserve events, it preserves processes. You can learn from a ruined city that a culture once flourished in a place and later declined. But Antarctica teaches on another scale. It teaches how climates reorganize, how feedback loops strengthen, how atmospheric conditions and ocean circulation combine to transform continents, how ice, once established, becomes a force that shapes not only local landscapes, but global sea levels, albedo, and climate balance. The buried world under Antarctica is therefore not merely a lost chapter. It is evidence of mechanisms. It shows how the Earth became the Earth we know now. This is one reason Antarctic science matters far beyond curiosity about the past. When researchers study Antarctic sediments, fossils, subglacial landforms, and ice cores, they are not only reconstructing a vanished world, they are also studying how planets respond to change. Warmer climates, cooling transitions, ice sheet growth, collapse thresholds, carbon cycles, ocean isolation, feedback between surface conditions and deeper systems. In Antarctica, the past is not dead data. It is a laboratory of long-term planetary behavior. Yet even that scientific framing does not quite capture the emotional power of the continent's archive. For that, one has to return to the contrast itself. Above, one of the starkest surfaces on Earth, white, wind-scoured, bright to the point of abstraction, a place so stripped down that it can feel beyond interpretation. Below, buried mountains, old valleys, sealed sediments, traces of ancient forests, records of warmer skies, evidence of animals moving through strange southern ecosystems under long seasonal light. The contradiction is immense. It almost feels unfair, as though the surface were deliberately misleading. But perhaps that is what makes Antarctica such a profound teacher. It shows how much reality can exist beneath an appearance that seems complete. It reminds us that surfaces are recent things, that the visible world is often only the thinnest layer of what a place truly is. The same is true, in a quieter way, of time. We tend to think of the present as solid because it is the layer we inhabit. Antarctica weakens that habit. It makes the present look fragile. If a continent can wear forests for millions of years, and then later wear ice for millions more, which version is the real one? The answer, of course, is both, and neither in isolation. Antarctica is not truly its green past or its frozen present alone. It is the full sequence. The real continent is the whole history, not whichever chapter happens to be visible at a given moment. That is what makes the phrase, "buried for millions of years," so important. It does not simply suggest age, it suggests endurance. The old worlds beneath Antarctica have not survived in open sunlight. They have survived by remaining hidden. Their burial is part of their preservation. A forest exposed at the surface for tens of millions of years would not remain a forest in any legible form. A river valley open to ordinary erosion, flooding, vegetation, and human disturbance would change beyond easy recognition. But Antarctica's ice, for all its harshness, has been capable of shielding records by shutting the door on the ordinary world. There is something almost monastic about that. The continent kept its archive by withdrawing from the rest of the planet. That withdrawal shaped the human relationship to Antarctica as well. Long before the science became rich enough to reveal the buried world in detail, the continent already had a reputation for distance, severity, and exclusion. It was hard to reach, difficult to survive, and resistant to settlement in any conventional sense. Even now, human presence there is temporary, controlled, and largely scientific. Compared with every other continent, Antarctica remains least absorbed into ordinary daily life. It is a place people study more than inhabit. That alone sets the mood for everything hidden beneath it. The archive lies not under farmland or cities or roads, but under the most aloof landmass on Earth. Perhaps that is why the idea of Antarctica as Earth's sealed archive feels so complete. The setting suits the role. And yet, what the archive contains is not coldness, not fundamentally. It contains warmth, too. That may be the deepest irony of all. Beneath the greatest modern symbol of frozen extremity lies evidence of green ages, flowing water, rich ecosystems, and atmospheres, unlike the present. Antarctica stores warmth inside cold. It stores former abundance inside apparent emptiness. It stores life inside silence. The continent is therefore not only an archive of extinction or burial. It is an archive of reversal. That reversal matters for the imagination, but it matters even more for thought. It teaches that no environmental identity is inevitable forever. It challenges the instinct to confuse longevity with permanence. It reveals that planetary systems can hold entirely different states across deep time, and that each state may one day look as though it had always been there, until enough evidence accumulates to say otherwise. Antarctica today looks inevitable. Antarctica's buried archive proves it is not. The longer one sits with that truth, the more the continent begins to feel less like an endpoint and more like a warning against shallow certainty. Not a warning in a loud or dramatic sense. Antarctica does not shout. It never has. It warns in the patient way geology always warns, by existing as proof that climates change, proof that ecosystems migrate or vanish, proof that land can be remade completely by long environmental forces, proof that what appears fixed may only be resting temporarily in one phase of a much longer cycle, proof that the Earth remembers more than the living surface reveals. And still, for all the scientific meaning and philosophical weight, there remains something almost intimate about the buried Antarctic story. Perhaps it is because, at its heart, this is still a story about worlds that were lived in. Forests once stood where now only ice shines. Creatures once crossed ground that now lies kilometers below frozen mass. Ancient rains fell there. Seasonal darkness came and went there. Rivers once found their channels, wetlands their edges, coastlines their tides. The continent's archive is not made only of data. It is made of former mornings, former seasons, former lives. Everything hidden beneath Antarctica was once simply present to itself. That recognition softens the grandeur just enough to make it humanly meaningful. Not because people were there, but because place itself was there, in a fuller sense than we now see. The old continent had texture, sound, growth, risk, abundance, decline. It belonged to living time before it belonged to archival time. Then the lid closed. Slowly, unevenly, irreversibly enough to create the Antarctica we know. And under that lid, the old worlds remained. It is tempting, when ending a story like this, to reach for the dramatic unknown, to suggest that the greatest Antarctic discovery has not yet been made, or that one hidden basin may overturn everything, or that some buried record waits below to change the whole narrative at once. But Antarctica teaches another kind of ending, a quieter one. Its power lies not in one final revelation, but in cumulative depth. The truth is already extraordinary enough. Beneath the ice lies not fantasy, but the preserved evidence of worlds so different from the present that they force us to rethink what continents are, what climates do, and how the Earth carries its past forward. If there is a final revelation here, it is this: the world does not lose its history when it buries it. It stores it. It folds it into rock, ice, chemistry, and hidden terrain. It keeps it out of sight until tools, patience, and curiosity become strong enough to reach some part of it again. Antarctica is the purest expression of that principle on Earth. The planet's coldest continent has become one of its most faithful historians. And perhaps that is why the place feels so haunting. Not because it is empty, but because it is full in ways we cannot easily see. Full of former climates, full of extinct ecosystems, full of geological memory, full of transitions so large that human language struggles to hold them cleanly, full of evidence that what is buried may still be speaking. So when people look at Antarctica and see only ice, they are seeing the last layer of a very long story. Under that layer lies a continent that was once green, then changing, then freezing, then sealed. Under that layer lie rivers turned to subglacial traces, forests turned to fossils, atmospheres turned to bubbles in ancient ice, living systems turned to records. Under that layer lies one of the planet's greatest acts of preservation through concealment. The forbidden continent, the unreachable continent, the silent continent, perhaps the truest thing that can be said of it, is simpler than all of those. It remembers. And before we leave this long southern night together, subscribe if these quiet journeys through the deep past are the kind of stories you like to fall asleep to. If you feel like it, tell me where in the world you're listening from and what hour has found you there. It always feels right to ask at the end of a story like this, because Antarctica makes the whole planet feel connected by time in a strange and gentle way. One place buried in ice, and countless others listening under very different skies. For now, the continent remains where it has long remained, bright, distant, silent on the surface. But beneath that surface, Earth's older worlds are still there, waiting with the patience only deep time can teach.